All right, today we're going to finish up chapter 6 by doing the topic on quadratic equations, section 6.5. The objectives that we're going to do is we're going to multiply binomials by the FOIL technique, and I'll explain that in a second. Then we're going to factor trinomials. I'll define those in a minute. We're going to solve quadratic equations by factoring, solve them by using the quadratic formula, and we're going to solve just general real-world application problems. So looking at all this, we first have to define what are quadratic equations, or QEs. They're equations with 2 as the highest exponent. We've been doing linear equations. Where the highest exponent was 1. So the general form of linear equations is like this. Where you see the exponent of x is 1. It doesn't have one, so it's 1. So the general form of a quadratic equation ax squared plus bx plus c, where the highest exponent is 2. Now, in algebra, if you ever take that class, you'll see that the exponents, the highest exponent, we call that the degree of the equation. The degree of the equation tells you 1, the maximum number of solutions possible.
Is this chapter
still 6.5? If you would have gotten here half an hour ago. So the degree tells us how many solutions we can have. It also tells us the shape of the graph of the equation. Maybe go down to the top there.
Oh, okay.
You can just come here and take it. See if you want to take a picture of this page.
It's okay. Well, is that all of it? Yes. Yeah.
This is page 7. So the degree tells us how many solutions. So for example, a quadratic equation or linear equation. Let's do that. Linear equation. Mx plus b. It's a straight line. Where the b is where the line crosses the y-axis. And m is the slope. So you see, since x, its exponent of x in the linear equation is 1, we only have one solution. Remember, solutions are where it's called the x-intercept. It's where the line crosses the x-axis. So whenever we talk about solutions of equations, we're talking about how many times or where they cross the x-axis. So that's a linear equation. Quadratic equation. Looks like this. Y equals ax squared plus bx plus c. That's the y-axis, that's the x-axis. Quadratic looks something like this. Or it could look like something like this. Y-axis, that's x-axis. Okay, similarly, with a linear equation, it can also look like that. The direction of the graph is dictated by the leading term, the farthest left term, the coefficient. So if m is positive, it goes up. If m is negative, it goes down. That's on a linear equation. So this equation of this one could look something like this. Y equals 3x plus 2. That's the example of this one. The other one could be negative 3x plus 2. Because if the leading term, the coefficient of the x, if it's positive, it goes up. If it's negative, it goes down. Same thing here. If a is positive, it goes up. If a is negative, it goes down. And in this case, the c is the y-intercept. So in any equation you have, whenever you set equal to y, solve for y, you get y by itself. In the equation, if you ever have just the number by itself, if you ever have a number by itself, that's always the y-intercept. The constant is always the y-intercept. So an example of this equation would be y equals 3x squared plus 2x minus 2. Why did I put minus 2? Because it's in the negative part, so it has to be negative. This one could be negative 3x squared plus 2x plus 2, because the positive is where it crosses. So far, so good?
So basically like the C or like are on the linear equation too, like where the B's at.
Is a B,
that's
right.
where it's the Y.
Yeah, it's the y-intercept. Yes. So you can put the constant number is the y-intercept. The constant number is the y-intercept. So just by looking at the equation, you can tell me where it crosses the y-axis. In other words, when I say constant number, there's no letter after it. It's just a number by itself. Remember, the degree also tells us the maximum number of solutions. Why did I say maximum? Because in linear equations, you can have an equation that looks like this. Yep, it'd be like this. It's a horizontal line going through the point 3. So again, since the linear equation is degree 1, it can have at most one solution. It can have no solutions. Same thing with quadratics. There's different of equations, but I'll show you what they look like. There are 3 possibilities here. One, it could look like this, where we have 2 solutions. An example of this one would be y equals x squared minus 2. What's the y-intercept? Right, negative 2 is the y-intercept. So we have 2 solutions. We can have one solution y equals x squared. What's the y-intercept of this one? 0, yeah, it's going to 0. Or we can have no solutions. If you look like this. No solutions because it doesn't cross the x-axis. So that's what they look like. That's why I said the degree, we can have at most 2, 1, or 0. So far, so good. So you can tell what the graph is going to look like basically by looking at the equation. See where the y-intercept is. You notice all of these are opening upwards, right? That's because the number in front of x squared is positive. If it's positive and the y-intercept is negative, we know we're going to have 2 solutions or 1 solution. If the leading number is positive and the y-intercept is positive, we're going to have no solutions. So let's see where they come from. The word monomial means mono means 1. Monomial means it's an equation that looks like this. Only has 1 term. One term. Or it could be a constant. Or it could be anything. A binomial, bi means 2. So it has 2 terms. And it doesn't have to be linear either. It could be x to the 7th minus x to the 3rd or 2nd. It could be anything, but there's only 2 terms. Remember, what defines a term? Anything separated by a plus or minus or equals, actually. Because yes, we have 3 terms, the y, the x, and the 2, but we call this a binomial equation because we only have 2 terms. So what do you think a trinomial would be? Three terms. Y equals x squared plus 10x plus 2. Has 3 terms. We're going to be dealing with trinomial equations because you see, the higher your description of the function, the higher your exponent. So a quadrinomial, 4 terms, would be x cubed, x squared, and so on and so forth. So it's always, if this is a tri, the highest exponent is 2. If it's a bi, the highest is 1. If it's a mono, it's usually 1 or none. So let's take it. We get trinomials by multiplying 2 binomials. I should put 2 similar binomials. For example, if the first binomial was x plus 2, and the second one was x plus 3 we treat that the same way if we had 3 times x plus 2. How would we multiply those together? Distribute. Whatever's in front multiplies to everything inside there. We do the same thing here. Whatever's in front multiplies to everything inside there. So it's x, this inside here, times x plus 2 plus 3 times x plus 2. So whatever's in front, I just put it behind whatever's inside the second one. And then I distribute again. X times x is x squared. X times 2, positive 2x. 3 times x, it's positive 3x. Positive and positive, 3 times 2 is 6. Whenever you get rid of parentheses, you always have to combine like terms. So we have positive 2 plus 3 is positive 5x plus 6. Now we have a trinomial. So the multiplication of two monomial equations or linear equations gives you a quadratic equation. This is quadratic. It's quadratic because it has a power 2. Okay, so, but there's another way. You guys heard of this one, the FOIL technique. Remember that from high school? Okay, let's look at the FOIL technique. Let's use the same numbers. We use the same numbers, x plus 2 times x plus 3. FOIL is an acronym. That's why there are periods after under each one of those. The F stands for first. The O stands for outer. The I stands for inner. And L stands for last. So the first term in each binomial, multiply them. That's your F. So x times x is x squared. Outer ones. The outer ones are those. Those are your outer ones. X times positive is positive. X times 3 is 3x. The inner ones are the ones that are close together. Those are the inter ones. Positive times positive is positive. 2 times x is 2x. And then the last ones. Positive, 2 times 3 is 6. Combine like terms. And there you have it. But the FOIL techniques only works when you have two binomials. It doesn't work on anything more, which is why I don't like teaching it. I like to teach distributivity better, like not like the first one we did. The way I like to teach it. Multiply each term of the first binomial by each term in the second. It doesn't even have to be binomial. It says in the first equation, the second equation. Because this way here works for no matter how big they are. So everything in this first parenthesis has to multiply to everything in the second. So we start with the first one. X times X equals X squared. X times 3, so they're both positive, is positive 3x. There's no more, so this one's finished. Positive times positive is positive. We do the next term. 2 times x, 2x. Positive, positive is positive. 2 times 3 is 6. So everything in the first equation multiplies in the second equation. And it doesn't matter how big it is.
I like
Oh yeah, these are gonna be much easier, because I think these are just straightforward stuff. So everything in the first parenthesis multiplies everything in the second. Let's look at x. X times x squared. There's 1 up here, so 1 plus 2 is 3. Positive times positive is positive. X times 3x. 1 plus 1 is x to the power 2. Positive times positive is positive. X times 4 is 4x. So that's all three of them for the first one, so it's finished. Now do the next one. Positive times positive is positive. 2 times x squared is 2x squared. Positive times positive is positive. 2 times 3 is 6x. Positive times positive is positive. 2 times 4 is 8. Then I combine like terms. I only have 1x cubed. I have 2x squareds, so I add the coefficients. 3 plus 2 is 5. I have 2 x's, so I add the coefficients. 4 plus 6 is 10. And then the 8. It's straightforward. And you know you did this part correctly, because we have 2 terms in the first one and 3 terms in the second. So 2 times 3, we should have 6 terms. 1, 2, 3, 4, 5, 6. So that you know you did that correctly if you have that. This one here, we have 2 terms in the first one, 2 terms in the second. So we should have 4 terms in this part. 1, 2, 3, 4. So we did that correctly, combine like terms. All right, so that's where we get binomials or polynomials. These are called, we never finished that one. This is x squared plus 5x plus 6. The combining term of all these things, they're called polynomials. Poly means many terms. It's just an all-encompassing term that describes everything, all the polynomials, binomial, trinomial, quadrinomials. The way we distinguish them is if we had, let's look at these guys. Let's see how we would name them. They're both polynomials. So this one is a polynomial of degree 2, because that's the highest power. This one is a polynomial of degree 3. So that's the name, that's how we distinguish all of them. We have a polynomial of degree 3. We have a polynomial of degree 4. Whatever the highest exponent is, that's the degree. So far, so good. That's just naming the nomenclature for it. Now, here's where you get to practice doing your multiplication of, let's do on your paper, get 4 columns. So 3 lines. Because I'm going to give you 4 separate binomial pairs and you're going to multiply them together. The first one, x plus 2 times x plus 3. X plus 2 times x minus 3. X minus 2, x plus 3, x minus 2, x minus 3. So what's different with those 4? What's different about them? Yeah, the only thing different are the signs between them. So multiply these 4 terms together. So the first one, we get x times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. So it becomes x squared plus 5x plus 6, right? We just did that one. Now these change because we have different signs. X times x, x squared. Positive times negative is negative. X times 3 is 3x. Positive and positive is positive. 2 times x. Positive times negative is negative. 2 times 3 is 6. So we get x squared, negative 3 plus 2. 3 is bigger. 3 minus 2 is 1. That one. X times x is x squared. Positive and positive is positive. X times 3 is 3x. Negative times positive is negative. 2 times x. Negative 6. So we have x squared, 3 minus 2, 3 is bigger. And then the last one. X squared, negative 3x. Negative 2x. Negative times negative is positive. 2 times 3 is 6. Negative 3, negative 2 is negative 5. So far, so good? That method is called distributing. We're going backwards now. Going this way is called factoring. Factoring is taking a polynomial and breaking it down to its linear terms. So you take a polynomial and break it down to its linear terms, to its simplest form. How do we do it? Remember, what is it? What does the degree tell us? How many solutions we can have? Yeah. So we're going to have two factors. We do it in pieces. First off, what makes x squared? Yeah, x times x. And they go in the first spot. This is where the FOIL part comes in. So the first thing is, here are the steps. What makes the first term? We figured out since it's x squared, it's x times x. Second step. Look at the second sign. The second sign is very important because it'll tell us what signs go in the equation. If it is positive, then both signs are the same. And they are the first sign. So if the second sign is positive, that means both of the signs are the same. They're whatever the first sign is. If the second sign is negative, then the signs are opposite. One's positive, one's negative. The bigger number gets the first sign. I'll explain what all this means in a second. So that's just looking at the second sign. The third step. Look at the last term. You have to figure out what times what equals the third term. That when you add or subtract them, you get the second term. And this plus or minus is whatever the second sign is. So if your second sign is a plus, it's what two numbers added together equal the second. If it's a minus, what two numbers subtracted equals the middle term. That's pretty much the steps. So let's see this. X times X is X squared. The second sign is a plus, which means what? They're both the same. This one, since it's a plus, they're same signs. What are the signs? It's whatever the first sign is. So this one, they're both positives. So that's step two. Step three, let's look at the last number, 6. What times what equals 6? When we add them, since that's a plus, because that's a plus, we get the middle term, we get 7. This is the bad nightmares coming back to haunt you. So what times what is 6? When you add them, you get 7. 6 and what? I thought you said 4. 6 and 1. So 6 plus 1. So these are the two numbers that go in our answers. 6 and 1. And there we have it. How about if I gave you X squared minus X minus 6? Okay, we know we have two solutions. So it's going to be like that. What makes X squared? X and X. The second sign is a minus, which means one's plus and one's negative. Now we got to figure out, look at the last term. What times what equals 6? When we subtract them, we get 1. Two times 3 and 3 minus 2. So those are the numbers. Since the first sign is negative, the bigger number gets the negative. That's what it means. So because you have two different signs in your parentheses, the bigger number gets that specific sign. So since that's minus, the bigger number gets that sign. How about this one? So we're going to have two solutions. What makes X squared? X times X. Then we look at the second sign. It's minus. So there'll be opposite signs. One's going to be positive, one's going to be negative. The bigger number gets that sign. So what times what equals 6? because that's negative, what minus gives us this number? Or no, that should have been plus. It wouldn't work the other way.
What do you mean?
Oh, yeah, it would. Yeah, it would. Yeah, it would. Yes, it would. So what times one is 6 when you subtract when you get 5? 6 times 1, 6 minus 1. So these are our two numbers. The bigger number gets the negative. That's factoring. Not as hard as you thought it was going to be, did you? If you would learn it this way, it'd be much easier.
I feel like I've like learned so much more here. Like, classes that I'm taking.
Thank you.
No, actually, like, there's not a lot of teachers that explain things right, so I didn't have trouble sometimes understanding. But like the way you explain it, it's like broken down and like.
That's what I try to do. Yeah, I teach the way I wish I would have been taught. 'Cause
Yeah.
I hear so. Thank you. It's let's try one more, and then we'll now show you why we're doing this.
I was like, oh, what classes do I need? You know, I was like, since I had like the spring semester off and I didn't want to miss anything.
Mhm.
He's like, well, you need math to graduate, might as well. Okay, might as well do math. I needed to graduate. So.
And this one is this your last class for graduating?
No, not necessarily.
Okay.
But he's like, oh, but you needed to graduate.
That's
now.
true.
So I was just like, I'm not gonna pull it like, oh, last minute. You know, just do it with the manager.
We have two solutions. The first term is x and x. The second sign is a minus. What does that tell us? They're going to be opposites. This one tells us that the signs are going to be opposites. One's going to be positive and one's going to be negative. So we figure out what times what equals 22. When you subtract them, it equals 21. Which is? This is the hardest part. I'm not gonna, this is the hardest part here because you have to go through so many different numbers. But once you find it, it's just plug and play. Since the signs are opposite, this says the bigger number gets that sign, the bigger number is 22, it gets the positive, and one gets the negative, and there you have it. Now, the question is, why are we doing this? Solving quadratic equations. Because now we get to solve problems using quadratic equations. So whenever you have an equation, before you can solve it, it has to be in this form. You have to get y by itself and everything else, x's and constants to the other side. Because Because if I gave you an equation like this, could you solve it the way it is now? No. What would you have to do? You have to get the y by itself. So what do you get rid of first? Always get, since this is the y, get rid of anything plus or minus to it first.
The positive 8x would be negative.
We put negative 8x over there. So we have 2y minus 4 equals 2x squared minus 8x. What else do we get rid of?
The negative 4
How?
plus 4.
Yeah, it's always a process of opposites. So we add 4. Two x squared minus 8x plus 4. And then one more step.
divided by
Yeah, since these are multiplied, divide each term separately by 2. So we get x squared. 8 divided by 2 is 4x. 4 divided by 2 is 2. Here, we're not going to solve this one. I was giving you an example. Now you can try to factor it, but this one won't be, it's not factorable yet. We're going to do that in the next half. So we have to make sure we get y by itself. So let's pretend we did have one already. We fixed one of them. Solve for that one. So we know we have to have 2 parentheses. So we know the first term is x and x. Since the second sign is a plus, what does that tell us? They're both the same sign. They're whatever the first one is, so they're both pluses. Because this is a plus, not because that's a plus, because that's a plus. Now we got to figure out what times what is 18. When we add them together, we get 9. 6 times 3 is 18. 6 plus 3 is 9. Excellent. So now, when you solve it, remember, the solutions are x-intercepts. X-intercepts occur when y equals 0. So we set the answer equal to 0. And we use what's called the zero product principle. Zero product principle. The zero product principle says this. What does product mean first? Product means multiplication. So if we have 2 numbers, A and B, and we multiply them and they equal 0, what can be true about A and B? Right, either one of them or both of them. Either A equals 0 or B equals 0, or they both equal 0. And since we don't know which one's which, we treat both of them as being 0. So we take both of these equations, since they're multiplied together, and we set them equal to 0 and solve for x. So subtract 6, x equals -6, subtract 3, x equals -3. These are my solutions. I'm supposed to have 2 solutions, and I have them. Those are my solutions. So once you factor them, take the factors, set them equal to 0, and that'll give you your solutions. Let's look at another one. Y equals x squared minus x minus 12.
That's so bad.
Those are good. I've seen one.
They're beautiful.
Yeah.
All right, so we have to set, first thing you do when you're solving, set y equal to 0 and factor the equation. X squared, x times x. The second sign is a minus. That tells us that they're opposite signs. So we gotta figure out what times what equals 12. That when we subtract them, we get 1. Now 4 times 3, 4 minus 3. And since they're the first sign tells us the bigger number gets that sign. So 4 is bigger, so 4 goes here, 3 goes there. Then what do you do?
X plus
Yeah, set them equal to 0. Subtract 3. And add 4. Those are your solutions. Of course, always check your answers. Take these one by one, take -3, put it in the equation, and it should equal 0. Take 4, put it in there, for example. Let's say x is 4, so we have 4 squared minus 4 minus 12. 4 squared is 16 minus 4 minus 12. 16 minus 4 is 12. 12 minus 12 is 0, so it works. So that's the factoring method. The factoring method won't always work. Because remember, the factoring method only works if you have a solution. Actually, let's try this one first. X squared minus 4x plus 4. We know x squared is made of x times x. The second sign is a plus that tells us they're the same signs. They're both minus. So what times what equals 4? That when you add them, you also get 4. 2 times 2, 2 plus 2. Set them both equal to 0, and you get 2. That's possible. Remember, what this graph will look like is at 2, that's our x-intercept. The graph will go up from there. In these, one of them is -3, one of them is +4, and it crosses at -12 because of that. In this equation here, we just did in the bottom, it crosses the y-axis at +4 because that's the constant. Actually, we can draw these graphs a lot better. We know it crosses or touches the x-axis at 2. It crosses the y-axis at 4 because it's constant. We know one more point. Because these graphs are symmetrical, they're even mirror images of each other. We go 1, 2, and 4 up. We go the other way. 1, 2, and 4 up. There's another dot. So we can draw our graph this way. So we go 2 this way, we go 2 that way, up 4, up 4. All right, the second way you can do these, the second method I'm going to show you all always works no matter what, is called the quadratic formula. In my algebra classes, I show you how we get this answer. This is the formula. But in this course, I'll just give it to you and you just have to write it down or memorize it. Because remember, we're solving for x's. We're looking for the x-intercepts. We start off with an equation that looks like this. And our solution will look something like this. There's one x value and there's two x values. So there's when we're asking to solve, we're looking for x. That's how come this formula starts off with x. It solves for x. Negative b plus or minus the square root of b squared minus 4ac over 2a. This formula will always work. Let's see. So our first example. X squared plus 9x plus 18. I'm going to use the same examples we just did to show you how it works. To use this method, to use the quadratic formula, the first thing you have to do is label A, B, and C. Remember, A is in whatever's in front of x squared. So what's in front of x squared? Positive 1, right? B is whatever is in front of x. It's a positive 9. And C is the constant. The reason you want to do that, make sure whatever sign's in front of the numbers, that sign belongs to that number. So a lot of people don't, but I tell them, always, always, always start off by writing your formula. It'll help you memorize it, and it'll help you not make careless errors when you put numbers in there. Now plug and play. The first thing, we have the negative sign. What's B? B is 9. Plus or minus B, which is 9 squared, minus 4 times A is 1, and C is 18, over 2 times A is 1. Now solve it. Order of operations. We have to do inside the radical first. What's 9 squared? 9 times 9 is 81. Minus 4 times 1 is 4. Then 18 times 4 is 72. That's what that equals. Over 2. Negative 9 plus or minus 81 minus 72 is 9. Over 2. Negative 9 plus or minus. What is the square root of 9? 3 over 2. All right, so now here's where the plus or minus come into play. Remember, in quadratic equations, you have 2 solutions. You have negative 9 plus 3 over 2, negative 9 minus 3 over 2. So you have to take 2 equations here. One has a plus, one has a minus. Negative 9 plus 3 is, since 9 is bigger, negative 6. Negative 6 divided by 2. There's our first solution. Negative 9 minus 3. They're both negative, so you add the numbers. Negative 12 divided by 2. Negative 6. And that's exactly what we got in our earlier answers. Let's do another one. X squared minus x minus 12. So there's a negative in front of b. B is negative 1. Plus or minus square root of negative 1 squared minus 4 times a times c over 2 times 1. Negative and negative is a positive 1. Plus minus square root. Negative 1 squared is 1. Negative times negative is positive. 4 times 1 is 4. 4 times 12 is 48 over 2. Because A is 1.
Oh, wait.
1 plus or minus 48 plus 1 is 49. The square root of 49. 7. We have 1 plus 7 over 2. 1 minus 7 over 2. 8 divided by 2 is 4. Negative 6 over 2 is negative 3. Those are your intercepts, so your solutions.
So,
Yes.
you go more up, where it's, -1 squared, yeah, that one. So you move in the radical or.
In here.
So you multiply -4 times 1.
Well, actually, remember, always treat the signs and numbers different. So it's 4 is negative. Negative times positive is negative. Negative times negative is, so we know it's positive. 4 times 1 times 12. If you treat them separately, then it's always going to give, it will take away the problem from you. Because yeah, if you try to do -4 times 1 is -4, -4 times -12, positive 48, it's a little cumbersome there. Because if all of them were negative, then we have a bigger problem. That's the end of chapter 6. Any questions?